5.6 Introduction to Inequalities. Now, inequalities are very much like equations. But there can be many, many answers. Instead of just the one that we've been studying in grade 9. Now, when you get a little bit older and you're going into, grade 11 and 12 pre-calculus, you're going to find systems with 2 or more solutions, and sometimes they have 0 solutions. But with this one, it kind of shows, with inequalities, it kind of shows a relationship. And I'll tell you what I mean. But first, let's focus on the notation. So you're going to see a few symbols that look like this. Okay, just remember, it doesn't really matter what the definition is, but you just have to remember Pac-Man eats the bigger number. So if I have an 8 and I should have done a 7. 7, 8, 9. 8 and a 10. I'm saying that Pac-Man is going to eat the bigger number. That means that the open mouth is towards the bigger number. Okay, so this one officially is less than. Because of Western reading protocol, we read from left to right. So that means that the thing on the left is less than the thing on the right. This one will be called greater than. This one right here is less than or equal to, because it has that extra equal sign. This one is greater than or equal to. And this is simply our equals. So for these guys up here, these are our inequalities. And this right here is for our equation. So far we've just been dealing with equations, but now we're going to add something new in the mix. So when graphing inequalities on a number line, we start our graph at the number with either a solid or hollow dot. For less than or greater than, we will use a hollow dot. For less than or equal to, or greater than or equal to, or simply just equal to, we will use a solid dot. So let's just graph the following inequalities. So x is greater than 3. So what I want to do first is I want to create my number line. I'm going to put my 3 right in the middle. There's no point in making a crazy number line because the only thing that we need to show here is 3. Now, we will be using a hollow dot because it's not less than or equal to. It's just, greater than or equal to. It's simply greater than. So I'm going to have this. I'm not going to fill it all the way in. And I'm going to say that x is greater than 3. That means that x can equal 5, x can equal 10, but x cannot equal 1, or x cannot equal negative 5, or negative 3. So the direction is this way. Now, some people really like to use the direction that the inequality is pointing to help guide them. So this one is pointing to the right, and so the inequality is going to go to the right. But I can also express this inequality using a different direction. So I'm going to say 3 is less than x. Now, intuitively, x is greater than 3 just makes way more sense. But like this is still legitimate. The big side is still pointing to the x. Okay, the wider side is still pointing to the x. This is legitimate. But this is still the graph for this. All I've just said is it's a relationship. It shows a relationship between the two values. So the x is greater than 3. So be careful. The only time that this works, pointing in the correct direction, is if the variable is on the left and the number is on the right. But it's important to know that these two statements are equivalent. All right, so j is greater than or equal to -1. So I'm not going to put on 0 or 1 or 2. I'm just going to put in my -1. Because that's the only thing that matters in this case. And I'm going to use a different color, or I can just use a different thickness of line. And I am going to put a dot around the 1. Now, it's greater than or equal to. That means it can be equal to 1, but it's also greater than anything that's 1. So I'm going to fill it in, because the inequality includes the 1. Oh, I don't know why I did that. I'm going to see if that works. Oh, stubborn. So this right here, even though it's not working, oh man, it's pretty funny. So it actually goes in this direction. Oh, there you go. Okay, j is greater than or equal to -1. Now here is what I was talking about with question A. Z is less than or equal to 4. So I'm noticing that my variable is on my right side, just to mess with you. Us math teachers, hey? So I'm still going to put my single number right here, which is going to be 4, because that's the thing that's right here. But I'm going to say z is less than 4. So that means that it's going to be here on this side. And we're going to use a, think about it, hollow or solid dot. You got it. We're going to use a solid dot because it includes the value of 4. But I say z is less than 4. So it's going to actually go in this direction. So just to write an equivalent statement here, we're going to say z is less than or equal to 4. So when we put the variable on the left and the value, the number value on the right, yes, it does point in the right direction. So it points, the inequality points, or the smaller one points to the left, and the inequality goes to the left. But really what I want you to get out of this is that the inequalities show a relationship between the two values, or the two quantities. It doesn't matter how or which side the letters are on or the numbers are on, but it just shows that the 3 is less than x, okay? Or this one right here, the z is less than 4. It shows a relationship. Now this one's kind of a little bit of a tricky one. Let's think about it. P does not equal 2. So I'm going to put my number line here again, and I'm going to still use that value, even though, okay, even though it does not equal it. So P cannot equal 2. But think about it. Can it equal 2.000001? Yes. Can it equal 2.00000000000001? Yeah, because that's not 2. So it's called infinitesimally close. Okay, infinitesimally close to 2, but it never actually equals 2. So I'm going to put a hollow dot around the 2. Okay, and I'm going to say that it can't equal 2. So P can be greater than 2. And P can be less than 2. It just can't equal 2. So if I think about it, if I put in a 0, yes, P can equal 0. And if I put in a 10 on this side, yes, P can equal 10. It just cannot equal 2.